Good morning, good afternoon, or whatever time it is where you are. This is Andrew Kamazinski at Hokkaido University of Education in Asahikawa, and this is a flip for a critical thinking class. So in this particular case, we are moving from rules for arguments that are general to rules for arguments that are specific. So general rules apply to all types of arguments. These specific rules apply mostly to one type of argument. And we could call this type of argument a inductive argument, or we could call it a generalization. So in Japanese, that would be ipanka for generalization. So let's get straight into the revised version of the PowerPoint. Okay. Rule 7, use multiple examples. So the first argument we can look at is a sample inductive argument. The first time I came to Asahikawa, it snowed. The second time I came to Asahikawa, it snowed. The third time I came to Asahikawa, it snowed. Therefore, it snows a lot in Asahikawa. The basic pattern for this sort of argument is we have multiple cases of evidence or data, and we use those to support our conclusion. So we call this an inductive argument. An inductive argument builds on experience to reach its conclusion. This experience can be direct, things that I myself see or hear, in which case it is chokusetsu kankaku, or it can be indirect, konsetsu kankaku, in which case we would call what we're using data. Usually, the sort of conclusion we make in this case is a generalization, an ipanka. So we are saying something general from things that are specific. Izure na rei kara ipanka wo suru. So what that means is that an inductive argument shows whether its conclusion is likely or not. So we aren't going to get perfect conclusions. So we could say probably it will rain tomorrow, or we could say something like it's going to be safe to eat, or at least safe enough that you should try it. Now, inductive arguments are strong or weak. And when we say strong, we mean that they can convince. Seitoku ryoku ga aru. And when they are weak, we mean that they cannot convince or they should not convince. So let's look at another inductive argument. The first time I came to Asahikawa, it snowed. It snows a lot in Asahikawa. This argument is weaker than the first argument. Why? We have less things that support what we're saying. So we have less evidence to suggest the conclusion is true. Sample inductive argument 3. The first time I came to Asahikawa, it snowed. The second time I came to Asahikawa, it snowed. The third time I came to Asahikawa, it snowed. Those 3 dots are called an ellipsis, or in Japanese, the concept is chūryaku. The 100th time I came to Asahikawa, it snowed. Therefore, it snows a lot in Asahikawa. This argument is stronger than the first argument. To see why, we have a first, second, third, all the way to 100, which is significantly stronger than the first argument we were looking at. It's also stronger than the argument that we just looked at because it has 100 points compared to 1. So this is the first argument, which is that it snowed in Asahikawa the first time that I came here. So here we go. It snowed in Asahikawa the second time I came here. It snowed in Asahikawa the third time that I came here. So from this, all 3 of them are the same. So that gives us a point. So then I want to say it snows a lot in Asahikawa. So that's not great, it's not terrible. Let's look now at the second argument. In the case of the second argument, we have only one data point. And now we want to say it snows a lot in Asahikawa. That's pretty hard to say. So is here. If we make the third one, then it's snowing 100 times. And from that, we're making the judgment based on this line that it snows a lot in Asahikawa. So that's a pretty good argument. There's a whole lot of data supporting it. It's not perfect, but just for the purposes of this rule, it's enough. So let's summarize this rule. The more examples make a stronger inductive argument. The more examples you have make for a stronger inductive argument. Okay, so if I want to prove that my wife likes flying squirrels, if I say that one time she looked at a flying squirrel and she said it was cute, that doesn't prove she likes flying squirrels, or at least not very much. If I told you she went to the zoo 5 times in 1 month to look at flying squirrels, then we can say she likes flying squirrels. Okay, rule 8, representative samples. So this rule is hard to explain with words, but I also made some images to try and make it easier. So first, what do we mean by representative sample? So the dictionary definition will be a sample which mirrors the data set as a whole. So what we mean is something that fits, something that isn't strange compared to what we want to talk about. So looking at some of the Japanese translations that I found online, daihyo sample is a perfect match. Reigai mono de wa nai. That's also a good match. Tentei tekina could be okay, but we definitely don't mean a daijin. We don't mean someone who is serving in the Japanese parliament. So let's see what we can do here. This is one way to look at what's representative or not. So we have red and we have blue. So if we use red to say something about red and blue, or to say something just about blue, it's a really bad idea because red is not very much like blue. There's no reason that we would use red to talk about anything other than red. Because if we look at blue, we could draw a line maybe here. But if we look at red, it has nothing to do with it. So we can't say, well, red is here and blue is here, so this. That's not very helpful to us. If we want to say something like that, we're going to need a whole lot of evidence to support that. Another example. Here we're in a little bit better territory. Here in this case, we might be able to look at something here and say this is representative or something here. But at least in this case, everything is in this region. So we wouldn't want to use this data point. It's far outside of what we're looking at. And maybe we wouldn't want to use this data point. But it seems like we could say things with data in this range. It's quite close to representing. 代表として立てる. Now, a representative sample is one that helps for what you want to know. We can't use red to talk about blue and red, and we can't use blue to talk about red. Instead, we need to pick something that fits with what we're trying to say. So if I want to say something about wolves, it doesn't make sense to use a squirrel as my test animal. So I'll repeat that. If I want to say something about wolves, it doesn't make sense to use something like a squirrel as my test sample or representative animal. Now, if I want to say something about wolves and I pick a wolf, we're a lot closer to picking something that we can say useful things from. So let me give a few examples, ones where we can talk about these questions. So everyone in my house can speak English. I live in Japan. Therefore, everyone in Japan can speak English. So if we go back, this is quite similar to this case. So yes, everyone in my family speaks Japanese and English. But we can all speak English. Now, part of that is that we are native English speakers. But that doesn't mean that everyone else also speaks English. So in that case, this is a bad sample. So most people in Hokkaido are Japanese by nationality. Most Japanese by nationality speak Japanese. Therefore, most people in Hokkaido speak Japanese. So I'll repeat that. Most people in Hokkaido are Japanese by nationality. Most Japanese by nationality speak Japanese. Therefore, most people in Hokkaido speak Japanese. So this is more similar to this case. So maybe there are some other things going on, but if this is someone in Hokkaido, and this is everyone in Japan on Honshu, then they all speak Japanese. It seems like it is fair to talk about this smaller data point and say people here probably speak Japanese too. Finally, most people I know in Asahikawa go to Hokkaido University of Education, Asahikawa. Therefore, most people in Asahikawa go to Hokkaido University of Education, Asahikawa. Is this representative? I think the answer is no. So we know this is not representative because we know that there are plenty of other people in Asahikawa. There are people who aren't in college, maybe they're children, maybe they're adults, maybe they're elderly. There are people who go to other universities like Asahikawa Iryo Daigaku, or they could go to Asahikawa University or any of a number of other schools, or maybe they don't go to a university. So again, this is a case where the data is not very well matched. So how do we test that? How do we know if a sample is a good sample, a representative sample, or not a representative sample? The answer is cross-section. So this is a hard word, but the meaning is not as hard as it seems. So the word in Japanese is danmen. And the question we're asking is how well does your basis represent the group you want to characterize? So this is some common sense. So if I want to understand people in Asahikawa, it probably doesn't make sense to ask foreigners in Asahikawa because there are only about 500 foreigners out of 400,000 people. Sample size. We also need to ask, did we ask enough people or do we have enough data to say anything about the rest? So if we only ask one person, so let's say I ask one of my students from Asahikawa what their favorite ramen shop is, that's not enough for me to say everyone in Asahikawa thinks this is the best. If I ask 500 people and all of them say the same thing, then we're a lot closer. So that reminds us of our earlier chart. Finally, sample source. How did I find the data? How did I discover what I'm using as data? So if I walk into my house and I ask the only person I find there questions, then that's not very useful if I want to say things about people in Asahikawa in general, or in Hokkaido, or in Japan, because that's not a random way of finding someone. I picked them, maybe not for good reasons. So we will look at that later in a different flip. So if we're talking cross-section, I want to just explain this one visually as well. So if I'm doing a cross-section, I need to pick where I'm gathering data from. So I need to ask, am I looking at something that makes sense? So for red, it's very hard to draw a cross-section. That's good. For blue, it seems like if I looked at this, I would know enough to say things just about blue. For red, it'd be very hard. If I want to just talk about these four up here, so if I just want to say something about them, then it seems like I could pick maybe this one, which is central to them. But then if I want to talk about everything, there's no good one thing that I can ask. So instead, I will need to do something like this. Instead, I will need to do something like this, where I'm looking at all of these data points together before I can draw a good conclusion. Next is sample size. So if I want to say something, if I only look at these two data points here, it's not very much. If I look at these three, these four, then these 8 altogether, I will say very different things than if I only talk about this one. Again, if I just grabbed all of this data, I could say things that make a lot more sense as generalizations. 一般化しながら大きなデータがいいでしょ? So our goal is a randomized cross-section. And the way that we can describe this rule is use a representative sample. Or if I wanted to say it in my Japanese, I might say 金を使っていない断面から一般化する. Okay, let's go on to rule number 9. Consider background rates. So let's go on to rule number 9. Consider background rates. So it's probably easiest to just use an image to understand this. So if I wanted to say something about red, if I look here, so I want to use this point to draw a conclusion. I think that's not going to be very useful. So if I want to draw my conclusion here, that's not going to be all that useful. Why? The answer is all of my data is random. So then this is something where I need to consider the background rate. Or to give another example, if I want to talk about, or to give another example, if I want to talk about red and I use these 3 points, I might say something. But if I look around, maybe I shouldn't say something. Same thing with blue. If I want to talk about, say, these 3 points or these 4 points, I could end up saying something that's false because I'm not looking at all of the other blue data. Or I'm not looking at all of the other red data. In either case, I'm ignoring the background. 背景を無視してる. So generalizations only make sense against the background. If we say Malaysia Airlines is not a safe airline because of MH370, we are saying because they lost one plane that they're not safe. But that only makes sense if we can look at the background. So let's say that's like this. So Malaysia Airlines has lost one plane. But the rest of these, let's say these planes are fine. And let's say this is a different airline that has also lost one plane. There's no reason for us to say Malaysia Airlines is less safe than other airlines from just one plane. Now, since MH370, Malaysia Airlines has lost another plane. Maybe as the number goes up, we're in a better place to say that it's not good. So white people speak English. Now, this isn't true, of course. There are people in France, Spain, Germany, Poland, Russia who are white people who don't speak English. There are people in Canada who are white people who don't speak English. So we need to ask, is Dr. K representative of all white people? To put it another way, since what we're doing is generalization, since what we are doing, what we need to do here is we need to ask ourselves, so what we're doing is generalizations. We need to ask ourselves, because what we're doing here is generalizations, are we engaging in generalization, which is okay, ipanka, or are we engaging in what in English we would call overgeneralization, which in Japanese would be ipanka shi sugiru. So again, not all white people speak English, and if we just think, we should realize one person won't tell us whether all white people speak English, whether all white people speak Japanese, whether all people of Japanese ethnicity speak Japanese. Third one, Japanese people have a hard time learning English. Maybe, but is this meaningful without background? So do Koreans and others have similar difficulties in learning English? Do Chinese people have an equally hard time? Or is it just hard for everyone? And we can only know this if we check our generalizations. I know that was a lot of content, so I hope that you are doing well. If you have questions, please feel free to comment on the YouTube video. If you're not from Hokkaido University of Education Asaikawa, thank you for watching. If you are, also thank you for watching. If the content seems a little slow, if you're a native English speaker, my apologies for that. If the content is too fast, please know that in YouTube, you can slow videos down. So you could watch this at 9/10 speed if you have trouble understanding what I'm saying. If you think what I'm saying is terribly wrong, please feel free to email me or to contact me, and I will do my best to revise these videos. All right, thanks, and have a good day.